Let's talk about what's going on. This is not dry ice. Okay? This is also sodium acetate and water. So when you snap this, instead of before, what I did was to put one single crystal in there in the solution, and it started crystallizing from that one thing. What I'm going to do here, when you snap this little button, it creates a shock wave. A tiny little shock wave, but a shock wave. And that shock wave is enough to push ions, push the water molecules out of the way and get the sodium and acetate ions to start joining together. So we're starting the same thing here, okay? We're doing the same thing as we did with the thing, with the Florence flask, except now we're just simply starting it crystallizing in a different way.
So could you just flick the bag?
Now, why is it hot?
I don't know. It's a reaction.
Chemical reaction, particles are moving.
All right. This is something that actually doesn't come along until Unit 10. So we've got sodium ions, and we've got these acetate ions. Okay? And they're separated in water. So they're aqueous ions, and they're going to join together to make sodium acetate that is a crystal, and it's a solid. Okay? Because we have a supersaturated solution. We have more acetate ions in here than it can typically normally handle. Okay? That's supersaturated. Okay? I've only got sodium and acetate joining together. That's all that's going on there. And here's why it's giving off heat. Here's why it's giving off heat. Here's why it's giving off heat. Bond formation. We're forming a bond between sodium ions and acetate ions. Bond formation is always exothermic. Bond formation is always exothermic. Now, I can reuse this hand warmer by heating it up and getting the ions to go the other way. So it goes this way. It separates. Because I take that heat that's given off, when I made the bonds, I put the heat back into it and get it to separate.
So, you put it in the microwave.
Well, you don't put it in the microwave, you put it in boiling water. Yep.